this video I'll walk you through the problem that asks you to calculate a future value amount, assuming there are periodic payments made over the life of this investment, which is a future value of an annuity problem. And so you've read through the problem hopefully, and I've kind of summarized it here visually for you, and it says you graduate right here, and I've got a timeline, and you're going to retire at age 52. We're going to assume you're 22 when you graduate, and you make a $10,000 payment on December 31st of the year that you graduate. And then you go ahead and you are very diligent. You make a $10,000 annual deposit into a low fee index fund, which is an investment fund every single year. Every single year, you don't miss any payments all the way until the year you turn age 52. You make your last payment deposit on December 31st, right out here. So you got this whole time span here, and I want to know how much money have we earned? What's the value of the account on the December 31st when you retire at age 52, assuming that your index fund makes an annual average rate of 8%, and that's compounded annually. So this is where the future value of an annuity table becomes relevant. And you could learn how to do this in Excel or on a financial calculator, and that would be appropriate. It'd work much quicker than the way I show you. But on the CPA exam, if you do sit for that exam, you're going to be forced to use these present value and future value tables. And so I'm going to show you again using that future value table, because we're looking for the amount out here. What has it grown to? What's the future value of this investment 30 years from the day you make the first investment? So 30 years have passed, 30 payments, and the formula I'm going to show you that we've been learning is this right here. We're going to calculate the future value, and that is equal to the size of the annuity. And remember, an annuity is nothing more than a steady stream of constant payments made at an equal interval over some period of time. So it's a $10,000 annuity because it's made December 31st every year 30 times. Okay, so the size of my annuity, and I could type this into the little box here because I'm going to build a formula off that. I have an annuity that's $10,000. So all I have to do is multiply that by some factor, but the factor comes off of a table, and so you're going to be given 4 tables on an exam or a quiz. You're going to need to be able to differentiate which table am I going to use. And the tables are very descriptive. I'm only going to pull you to the right table here. This is the future value of an ordinary annuity. It's an ordinary annuity because the payment or the deposit is made at the end of the period. So listed along the y-axis again are the number of payments or number of periods, and across the x-axis is the rate that we're going to assume we're going to earn per period. And I told us we earn an 8% rate, and we make 30 periodic payments. So I go down until I find 30, and it looks like it's right here. 30, if I go over here, yep, that's the 30 payments, and this is the 8% column. And so this is my factor, 113.2832. 113.2832. That's my factor. All I have to do to get the future value is to multiply the annuity times that factor, and there I can assume that my investment will grow to over $1 million over that 30 year period. And to retire at 52 is very young. So you could have you could extend this and say, well, what if I waited until 62? Well, then you'd go over here and you'd pull down the 40 year, and you can see that it's going to grow significantly more. Right here, 259, we have more than double that. So anyways, that's the answer to the problem, is a 1.1 million.